Question 27. Okay, two ice skaters, A and B, start together on the ice. They push apart and they move off in opposite directions. Okay, so this is before pushing and this is after pushing. Okay, use the data and your knowledge of momentum to calculate the velocity of skaters A after pushing. Okay, so there's two things we'll need to remember about momentum. The first one is how to calculate it. So momentum is mass times velocity. So the momentum of an object is its mass times its velocity. The other thing that you need to remember is that the total momentum before something happens is the same as the total momentum afterwards, so long as there's no kind of external forces that are acting. And that's why they always put these people on ice, because then there's no friction or very little friction, or they might put them in space. They tend not to put them like just on normal ground. So anything that's on ice, you can pretend there's no friction. Okay, so we must say momentum before, or the total momentum before, equals total momentum after. Okay, so the total momentum before, well, it's the mass times velocity for each of these people added together. Well, 60 times 0 is 0, plus 90 times 0, which is the mass times velocity of that one, is 0. So it's 0. So the momentum at the beginning is 0. That means that the total momentum afterwards is also 0. So we've got here mass is 60. I don't know the velocity, so I'm going to put it as a question mark. Right, so now we know that 0, which is momentum before, is the same as momentum of this one, so 60 times question mark plus 90 times 2. Okay, so now we have 0 equals 60 times question mark plus 2 times 90, I think that's 180. 2 times 90 is 180 plus 180. Okay, now I have to rearrange that. So to get rid of, I'm looking for the question mark. So to get rid of that, I'm going to take the 180 to the other side. So I'm going to subtract 180. So minus 180 is 60 times question mark. So the question mark is minus 180 divided by 60. That's just dividing both sides by that. So minus 180. So minus 180 divided by 60 is minus 3. Okay, so minus 3 is question mark. So the velocity of skater A is minus 3 meters per second. What do we mean by minus 3? It means in the opposite direction. So i.e. opposite direction to B. Okay, so that's the long-winded way of doing it. Okay, it's the correct way of doing it. It's momentum before and momentum after. It's long-winded, but it will always work. It's just a bit of a long way of doing it. The other way you can do it is just by looking at proportions. Okay, so we know we start off with no momentum. So when we finish, there's no momentum either, which means that the momentum of A that way is the same as the momentum of B that way. Now, the bigger one, the heavier one, is going to go slower. You know that if you try and push on something. If you push something that's heavy, it doesn't move as much as you do if you're sort of sitting on ice. So this one is going to move faster, this one is going to move slower, and the speeds that they go are going to be in proportion to the reverse of their masses. So the smaller they are, the faster it's going to move. So A is 60 over 90 times as heavy, which is 2/3. So it's 2/3 the mass. Okay, that means that it will be, turn that upside down, 3 over 2 times the speed. Okay, so 3 over 2 times 2 meters per second gives us 3 meters per second. So it's going to be 1.5 times as big because it is 2/3 the mass. Okay, it's the inverse proportion. Okay, B is 1.5 times as heavy as A, so A will go 1.5 times the speed of B. Okay, it's the same ratio but the other way around. Okay, it's a slightly different way of doing it. It's a little bit more intuitive. Don't worry if you can't get it that way. One of these ways you'll need to be able to get though. Okay, but if not, you might be able to get some of the marks by just saying momentum before and momentum after and calculating one of them.